Hello and welcome to AWS and VMware webinar series. Today we're going to be talking about maximize the value of Microsoft SQL Server investments with VMware Cloud and AWS. My name is Gary Hamilton. I'm a cloud solution engineer with VMware and I'm co-presenting with James. James, you want to introduce yourself?
Hi, I'm James Devine. I'm a solutions architect on AWS, and I have an area of expertise in VMware and networking.
Thanks, James. So let's get going. Change the slide, please, James. So the agenda we're going to be covering today: an introduction to VMware Cloud and AWS, then a discussion about the migration of Microsoft SQL Server workloads to VMware Cloud and AWS. And then we're going to be going through a fascinating architecture of MS SQL workloads on VMware Cloud on AWS, integrated with AWS native services. So next slide, please, James. Now, customers who are going through the exercise of migrating application workloads to the cloud have discovered that 60% of the costs associated with migration, 60% of the costs are related to migration 60% of the costs of migration is related to reworking that application. And with regards to the time it takes to migrate that application, 90% of the time is related to application rework. Next slide, please, James. Now, customers are seeking an integrated and hybrid approach. They'd like to be able to take advantage of the capabilities that they have on-prem, using familiar tools and processes, leveraging the investment that they've made in skills and in skills and capabilities on that application on-prem. They'd like to be able to take advantage of their unique hardware configurations they've created for those applications. And they'd also like to have more granular control of the placement of those applications in their data. But at the same time, they'd like to take advantage of the key capabilities of the public cloud: scale faster, reduce costs, take advantage of the global footprint, pay as you go, and also access a broader range of services. Next slide, please, James. And for this reason, AWS and VMware jointly engineered the VMware Cloud and AWS service. Now, the VMware Cloud and AWS service deploys software-defined data centers on AWS bare metal servers. Now, the software-defined data center, or the SDDC, is made up of three components: vSphere for virtualizing compute, vSAN for software-defined storage, and NSX for software-defined networking. And at a click of a button, this is deployed onto bare metal servers within AWS's infrastructure. And these servers are integrated on the network backend to ensure that all VMs on workloads that are running in those SDDCs have access to AWS services. And a vCenter is deployed with each SDDC, and that vCenter can be integrated with your on-premise vCenter and therefore give you the ability to manage this SDDC from your existing vCenter. You're also able to migrate applications and do large-scale migration using a tool called Hybrid Cloud Extension, or HCX, and that facilitates rapid deployments using traffic steering and traffic engineering to rapidly migrate these applications and securely migrate these applications from on-prem to VMware Cloud and AWS and back. The service is sold by VMware and AWS. It's operated and supported by VMware. With this service, you can, from scratch, deploy a brand new SDDC in just 2 hours, and it just takes 10 minutes to add a new host on demand. Being able to, in addition to standing up the service from scratch in 2 hours, adding a new host only takes 10 minutes. And when you compare this to the time it takes to deploy a new host on-prem of 86 days, then you can see how flexible this solution can be for on capacity demand. Next slide, please. The service is available across 16 of the current 21 AWS regions. You can see on the left-hand side all the regions in which it's available, and those are represented by the green dots across the globe. So the service is currently available in US West and US East. It's available in Europe, in London and Frankfurt and Ireland. It's available in Asia Pacific, in Sydney. It's also available in Tokyo and Seoul and Mumbai, and it's also available in Paris and in Canada. And for US government requirements, it's available in US Gulf West. We'll be deploying second half of this year into Sweden and China and US Gulf East and Bahrain. And next year, we'll be deploying into Osaka. Next slide, please. From a use case perspective, these are the use cases that customers are utilizing the platform for. For data center extension, customers are seeing that the platform is very good for being able to deploy test and dev workloads very quickly, to be able to burst with virtual desktops, and also to be able to expand on demand when they have capacity requirements on extended capacity requirements that can't be met on-prem. Playtika is a good example of a customer who had this requirement where their on-prem data center was just about full. They desperately need new capacity, and within 5 days they were able to deploy over 600 workloads into VMware Cloud on AWS and extend their existing data center. For disaster recovery, it's a great use case where customers no longer want to maintain a secondary site. They can use VMware Cloud on AWS to complement their existing DR solution, replace their existing solution, or create a new DR solution. And PHP Mortgage is another customer who didn't want to remain in their secondary DR site, and within a very short space of time, I think it was about a week, we were able to migrate over 300 workloads from their DR site onto VMware Cloud and AWS. For cloud migrations, customers have requirements for sometimes refreshing their existing infrastructure. They're looking for somewhere to swing their applications to so that they can easily upgrade or refresh existing infrastructure without affecting those workloads and then swing them back. Some customers don't want to manage data centers anymore because there's no value in managing data center. The value is in managing and delivering the applications, and they're evacuating their data centers. And in some cases, they want to move a specific application to the cloud to take advantage of the services that are in the cloud, and therefore they move the application for those reasons. And Black Mountain is one such customer who wanted to evacuate a data center very quickly, and we were able to facilitate that. And then for next gen applications, customers are utilizing the platform to create hybrid applications, which are applications which stretch from private cloud to public cloud. And also they're looking to build out new applications very quickly, and they use this platform for that purpose. And also application modernization is a use case where Stagecoach was seeking to update an application which manages their 8,000 buses across the UK. That application is very important for their business. The buses send data every 30 seconds to this application. They were looking to increase the availability of that application, and they use this platform for that purpose. They moved 47 terabytes and made the application more available on the platform by creating a stretch cluster, and they did that in just 3 weeks. So a wonderful reference for next generation application modernization. Next slide, please, James. So when looking at SQL workloads, there are 3 different types of workloads, basically. You have online transaction processing, which involves a lot of transactional data, very high numbers of IOPS. And for these types of applications, using the TPCE benchmark is a very good way of being able to test that workload on VMware Cloud and AWS to ensure that it meets the requirements of that application. It's always good, and I'm sure the application teams will insist that before moving a particular workload, appropriate testing is done to ensure it meets their requirements. So in the case of OLTP, TPCE is a benchmark test that we also use to validate that the application runs efficiently and effectively on VMware Cloud and AWS. Online analytical processing, those are usually the business intelligence type apps. Those applications are very RAM intensive, and TPCH is a very good benchmark for testing those types of applications on VMware Cloud and AWS. And for business continuity type workloads, which includes backup, restore, database refreshes, those do heavy sequential reads and writes. So those are the 3 different types of SQL workloads that would be moved onto the platform, and appropriate testing should be done to ensure that those workloads deliver on the performance requirements for the end users. Next slide, please, James. So for me, in migrating the application, it's always good to ensure that you have a good architecture and you plan appropriately and therefore this will lead to a successful migration. Now, the same rules generally apply to deploying the application on-prem as to migrating it to VMware Cloud and AWS. You need to ensure that you right size for the application that you're moving. You don't want to deploy too many vCPUs in VMware Cloud and AWS because you'll end up having long ready times, which will affect the performance of the workload. You also want to ensure that you collect all the requirements, both technical and business requirements for the application, so that those can be met appropriately on the platform. You want to take into consideration all the risks and assumptions and constraints, like geolocation for data is something that needs to be considered. You need to develop a high-level architecture and logical design, just as you would on-prem. And this will ensure that you will have a successful migration, and also operational considerations need to be made. How are you going to back up? The backup solutions you have on-prem is probably not the appropriate backup solution for the application in VMware Cloud and AWS, at least the location of your backup, where you wouldn't back up from VMware Cloud to on-prem. It would probably be better to back up into AWS. So those are the types of considerations that need to be made. How do you monitor the application and so on? Next slide, please, James. When migrating the workload, you have to consider whether it's a standalone instance of SQL or is it a cluster. If it's a standalone migration, then as long as all the prerequisites that we just discussed in planning for the migration have been met, and you've prepared the target SDDC for the migration, then it's a simple vMotion that can be used to migrate the application across to VMware Cloud and AWS. If it's a cluster, then the approach to take is to change your replication to asynchronous, move the secondary nodes first, and then fail over to the secondary node, and then migrate the primary. Next slide, please, James. Some of the advantages of, one of the advantages of using VMware Cloud on AWS is that you get more high availability options when you've moved onto the platform, as well as facilitating the high availability options that you're used to on-prem. In VMware Cloud on AWS, vSphere offers you high availability capabilities. So if a host fails, it ensures that the application survives that host failure and it's moved into other hosts in the cluster. And also, as I briefly mentioned earlier with regards to the Stagecoach use case, stretch clusters are available so that you can survive the unavailability of an entire availability zone, where the cluster is stretched across two availability zones, and a vSAN stretch cluster is created, and that protects you against an availability zone failure. With regards to the features that you're used to on-prem, availability groups, there are no support restrictions. You're not required to have shared storage. Both synchronous and asynchronous replication is supported, and this can be combined with both on-prem and VMware Cloud on AWS, where you can have instances in both locations. From a failover cluster instance capability perspective, this is supported on VMDKs on VMware Cloud on AWS. It's also supported across stretch clusters. It can be combined with availability groups. There is a requirement that you have to be at a hardware level version 11 to support this. And in configuring it, you simply set the SCSI bus to physical to facilitate the configuration of the failover cluster instance. Next slide, please, James. So I'll hand it over to you now, James.
Sure, thanks. So now that we talked about some of the basic components of VMware Cloud on AWS and some of the use cases and how you'd use it for SQL Server specifically, we're going to go and break down a reference architecture. So that one of the exciting things about the VMware Cloud on AWS offering is that we're taking that SDDC and moving it into the VMware on AWS Cloud. So it's run in the same data centers that we run all of our other AWS services out of, which means that there's a lot of very interesting and native ways you can leverage AWS services within the VMware Cloud on AWS cluster. So we'll go through that in this high-level reference architecture. So we have on the very left side our on-premise data center, and then we have an AWS region, and there we have a customer VPC, which is in an AWS account that you own and manage. There's also on the right a VMware Cloud VPC, and that is in an AWS account that VMware owns and manages on your behalf. So it's important to keep in mind that the VMware Cloud in AWS is delivered as a service. So you're not going racking and stacking hardware. You're just making API calls to provision a cluster and add and remove nodes. So the same way that you'd programmatically access AWS, you access the VMware Cloud in AWS. They also have their own specific console to log into and provision the cluster. So we'll dig into what all of these individual components mean and build out this architecture step by step. So the first step here is for our networking. On-prem, we have an NSX Edge appliance. This allows us, even though we're not running NSX natively on-prem, it's not a requirement, we can use this Edge appliance to allow connectivity into AWS, into a virtual private gateway. And that can be done over Direct Connect or VPN. That allows us for connectivity into my VMware or my AWS account that I manage. And then over that Direct Connect, we'll set up a Microsoft Managed AD. which is a directory that's fully managed by AWS. So you just go into the console and launch the directory service, and then you can connect into it. From there, we'd set up either a one-way or two-way trust with the on-prem environment. So the direct connect is giving us the layer 3 connectivity, and the VPN is giving us a backup connection there. And then we're able to set up a cloud directory and sync that with our on-premises environment. We could also use another AWS service here called AD Connector. There are some customers that don't want to extend or have to worry about setting up trust. So we also have AD Connector as an option here as well to get that hybrid integration with our on-premise Active Directory. Our next step here is deploying our always-on availability groups in a stretch cluster. So the way a stretch cluster works is typically we build a SDDC across one availability zone in AWS. And if you're not familiar with that nomenclature, within a specific geographic area, AWS establishes regions. So you might have heard of US East 1, US East 2, and then we have other ones available in Ireland and around the world. So that would be your region. And then within a region, we have availability zones. And an availability zone is one or more data centers. So traditionally, when you deploy an on-prem VMware environment, you can think of that as almost being like one availability zone because you're only operating in one data center. Whereas by leveraging multiple availability zones, you can have your infrastructure span multiple data centers. And that really improves your high availability and your ability to tolerate loss. So in this type of environment, we're replicating the storage on the SDDC, the software-defined data center. So if there were a problem with one of our nodes, it would fail over automatically to another node in an SDDC run in another availability zone. So it allows us additional fault tolerance, even greater than we can get with a single SDDC that isn't in this stretch type of setup. So we can deploy our stretch cluster on this, on the VMware Cloud and AWS environment, and then provision our SQL servers. So here we see we have 2 SQL servers, and both are primary, and they're being replicated through that stretch cluster. So we don't need to handle that replication ourselves. Another point of interest here is on this bottom right, we see this VMware Cloud E&I. One of the things that we do between the customer AWS account that you own and the VMware managed account that VMware owns, we create a connection into those 2 environments. So it's high latency, low bandwidth high-speed connectivity between your VPC and the VMware Cloud and AWS VPC. So this allows me to reach into my VPC and have access to that managed directory that I have set up and running with a connection to my on-prem environment. So I don't need to actually extend any type of AD servers in this environment. I'm using the AWS managed AD service for Microsoft AD. We then need to set up a witness server. So this checks the health and makes sure that one or the other servers is the right one. One's primary, one's passive. So by file server, I set in a 3rd availability zone in my customer VPC here. This allows me to have that running in a third data center, if you will, by being another availability zone. So I'm leveraging 2 availability zones for my stretch cluster, and then I'm able to have my witness server running in a native EC2 instance, and again, have that connectivity back to on-prem. So typically a file share is what you'd use for that witness server. So you can determine which of the nodes is healthy, and you avoid a split brain type of operation. The nice thing here, we can start to leverage other native AWS services for load balancing. So here we're putting in a ELB, an elastic load balancer. We could also use a network load balancer or an application load balancer. This allows us to take services which may not necessarily be highly available or even load balanceable in many environments, and we're able to put them behind a load balancer and have that high availability built into the environment. And we don't need to manage that service. It's not like we're strapping in a bare metal type of load balancer like you would in an on-premise environment. Since everything is managed by AWS, we're able to just use our Elastic services in your customer VPC and then load balance to services running in your VMware Cloud and AWS environment. Another service that we can integrate with here and use is Route 53. This is AWS's managed DNS service. It's one of the few services that we actually have a 100% SLA for. We pretty much guarantee it won't go down, and that's built on a global infrastructure. So we're able to integrate with this global DNS and provide a highly available, fault-tolerant DNS resolution, and that works around the world. So another way to leverage a native AWS service. Another service that we can use is S3, the Symbol Storage Service. This is one of the core AWS services. The advantage there is it's low cost to store, from 2.5 cents down to fractions of a penny for our Glacier, our archival storage, and we have a cold archival storage as well. So that runs the spectrum of different tiers of storage that you can store things on. So especially for this type of environment, it might be that you back up your copies of your SQL database directly to an S3 bucket and can store those transactionally integrant log copies for extended amounts of time based on regulatory needs or just for your continuity of operations or DR type of scenario. Putting everything on S3 gives you 11 nines of durability with 4 nines of availability. So that's a great place to store backup copies or primary source and static content. And because we're running in the AWS environment with this VMware Cloud and AWS, if we access native services like S3, there's no access fee. Whereas if your VMware Cloud and AWS cluster was running in an on-premise environment and you went to download a file from S3, you'd be charged a data egress fee. If our SDDC is up and running in the AWS cloud and we're accessing S3 in the same region, we can download those files at no fee. So on this type of environment, then we build our SQL Server apps. So we can deploy those, and we have a number of options here. These can be in our native EC2 running in our VMware, or running in our customer VPC on the left side of this screen, or it could be on the right side where we're running it with the VMware Cloud on AWS. And it could also be in an on-prem environment too, since we have that connectivity back to the on-premise environment. So there are really a lot of flexibility in how I deploy instances, or do I deploy in EC2? Do I deploy in EC2? Do I deploy it in a VM native on the SDDC? And if I do that, do I deploy it on-prem or in the cloud? And the answer is I can deploy wherever I want and have that flexibility to move my workloads around as needed. Another service we can integrate with here is Amazon CloudWatch. This is our central logging and alerting type service. So by default, pretty much every AWS service reports some type of metrics to CloudWatch. Within our instances, we can report metrics directly to CloudWatch. You can think of it as, insert your favorite monitoring software. We can do that, and for basic metrics, we do it for free. You can build dashboards and set up alerts. Within VMs running both on-prem and in the VMware Cloud on AWS environment, we have a client that you can install that will actually export your logs into CloudWatch. So you can, as you start to move your applications into a cloud environment, you can start really taking advantage of these cloud native services, many of which we offer for free or very little cost. And when there is cost involved, it's all pay-as-you-go pricing. So we can leverage that CloudWatch there for monitoring. So if you look at this end-to-end, all these components, we can see, following from the steps down, we have our AWS and VMware Cloud on AWS environments, and they're linked together. We're using a virtual private gateway for extending our network connectivity from our on-prem environment into our VMware Cloud and AWS environment. We're also using Direct Connect or IPSec VPN tunnels directly into our VMware Cloud and AWS environment. That gives us layer 2 connectivity, or layer 3 connectivity, so we can connect into our vCenter and manage that and set up a hybrid environment. We can also use IPSec for that, or use IPSec as a backup. If we're going to be doing vMotion and moving VMs around, then Direct Connect is more of a requirement. Moving on to component number 4, once we have all of our connectivity set up, we do a 1- or 2-way trust between our on-prem environment to the cloud managed directory running and managed by AWS. Moving on to 5, we can also have an EC2 instance running domain controller, and that can have a trust to on-premise or not, or leverage our cloud native managed AD. Moving on to step 6 here, we have our SQL Server always on availability groups set up on our SDDC stretch cluster. So we're running that cluster across 2 availability zones for high availability, so we can fail over pretty seamlessly. We have step 7, we have EC2 instance running the file witness server. So that's making sure we don't have a split brain, and we can always tell who the proper active server is for our always on availability group, and it helps manage the quorum there. For step 8, we've integrated our Elastic Load Balancer, ELB, and we can either use an ALB, an NLB, or an ELB. That allows us to load balance across EC2 instances, but it can also load balance across VMs running in our SDDC as well. So we can take traditional applications that aren't necessarily easy to load balance and load balance them with our native services that we manage for you. Moving on to step 9, we have Route 53, so we can provide global DNS for your Elastic Load Balancer, your instances, and your VMs. Pretty much anything that needs a public name, we can provide that. We can also provide certificates for those names for free through our ACM or certificate manager service as well. Moving on to step number 10 here, we have our on-prem and cloud applications that want to access the SQL Server. They can do this one of 2 ways, either directly through that connection we have to the VMware Cloud and AWS environment, or through our customer VPC that we have set up. So we have that hybrid connectivity to our on-prem environment. We're able to natively access the VMware Cloud and AWS environment just as if it were another rack sitting in our data center. Then moving on to step 11, we have our S3, which provides an expensive backup storage. So it's our object storage, our simple storage service that can have multiple tiers down to fractions of a penny. If you have those type of archival requirements, you can archive off. And then we're using CloudWatch logs as our final step to monitor everything and have that alerting across all of our on-prem and EC2 instances and VMs. So we have that single pane of glass through CloudWatch into all of our logs, everything going on in our AWS environment, but then also in our on-prem environment, because we're able to export those logs. So a question that often comes up when we talk about this type of environment and running your traditional on-prem applications in the cloud is licensing. So the nice thing is, since this is a dedicated bare metal environment that you're running in an AWS data center, there's no charge, no change from your on-premise licensing agreements. So if you have an EULA already, then you would just need to make sure you have additional enough capacity to run the VMs that you'd run on-prem in the cloud. You might need to modify that agreement to include more licenses. But however, the good news is, however you're licensing your Microsoft environment today should be easily extendable into the cloud. And even if you don't have software assurance, you can leverage the license mobility to move your licenses into the cloud. So you do have a lot of flexibility and freedom there. You can also, being the VMware environment, you can specify the number of cores and RAM that you want for a specific VM, which is something that, in our native AWS offering, we don't really give you as much ability to control those levers on RAM. So you might want a 2 CPU SQL Server with 64 gigabytes of RAM, and that's just not a configuration we have natively in AWS. So you do have the ability to come up with some interesting sizing there. For supportability, it's fully supported to run, it's just vCenter, ESXi, the same type of software you'd run in your on-prem environment, but in the cloud. And there's no limitations or special certification required for VMware Cloud and AWS. Anything that's certified to run on VMware will pretty much run on this offering without any issues or additional work there. So it does provide a really nice hybrid solution for you to extend your on-prem environment, your on-prem vCenter environment into the cloud pretty seamlessly. So wrapping up, there's a number of advantages to running your Microsoft SQL workloads on VMware Cloud and AWS. You have a faster path to cloud. We have customers that have moved hundreds of thousands of VMs over the weekend from an on-prem environment to a VMware Cloud and AWS environment, and they're not looking back. They do have the ability to move back, but they're not, because things just run faster, better, and there's a number of advantages there. There's a low risk to a lift and shift migration. It's pretty much a vMotion, so we can vMotion live from your on-prem environment into the VMware Cloud and AWS environment, and we can also do a layer 2 VPN where we actually take the same subnet that you have in your on-prem environment and extend it into the VMware Cloud and AWS environment, which means that you can move your virtual machines from on-prem to the VMware Cloud and the AWS environment and vice versa without having to change the IP address. So it makes the leverage there very, very low and easy to move back and forth. So easy to move onto the cloud, but then easy to move back to on-prem if you need to as well. It's leverages the proven VMware stack, both on-premise and in the cloud. It's VMware the same. Once you start leveraging the VMware Cloud and AWS environment, that's where you can take advantage of AWS native services like S3, our simple storage service. We have over 140 native AWS services, and we're growing and innovating every day. So there's just always more and more to leverage and use from AWS. There's also full support for SQL Server high availability options, which include clustering and shared disks. So one of the things that you can't do natively on AWS is shared disk and some of the multicast traffic that some of these configurations require. So we're able to do that natively in the VMware Cloud and AWS environment because we can have shared disks, which allows us to set up failover clusters in ways that aren't always possible in the VMware Cloud and AWS, or in the native AWS environment. Next steps. So hopefully you found this presentation interesting, and it's piqued your imagination for some of the things that you can do with the VMware Cloud and AWS environment, and how you can leverage the ability to migrate your workloads from on-prem to AWS and to run them in a hybrid fashion. So if you contact your AWS or VMware representative, we can set up a proof of concept and pilot. And I think the really exciting thing for me, being an engineer who's had a lot of experience with VMware, is you have the best-in-cloud hypervisor on the best-in-cloud cloud providers. So you really get the advantage of both teams, and we work jointly on this offering. So it's not like it's just an AWS or just the VMware offering. We work together to help engineer a solution. So VMware from the SDDC side and AWS from the AWS side, and using our services, we really help you end to end get that up and running. You can get started with VMware Cloud and AWS now. It's available here. We have an offer running on where you can get 3-host software-defined data center for the price of 2 hosts, and that is good until August 2nd. So a good way to, if you know that you'll need at least 3 nodes to lock in that capacity savings now while that offer is still going. We also have a VMware Site Recovery Manager promotion. If you're familiar with SRM, that's the disaster recovery as a service option. So you can leverage a cloud and VMware Cloud and AWS environment as a backup target for your on-prem environment, or for another region that you have running the VMware Cloud and AWS offering. So a great way to have simple disaster recovery. So we have free site recovery add-on for up to 90 days for maximum of 200 VMs. So there's a link there to get signed up for that. We also have additional resources where you can go if you want to learn more information about this product and offering. And I'm sure we can send out a copy of the notes, and you'll get these links here. with that, we'll move on to some questions.
Yes, are there any questions? There was one question about the difference between running, the advantage of running on VMware on AWS versus EC2. I think you addressed that, James, in one of the slides talking about some of the capabilities that are available.
Yeah, I can dig in there. So it's not, a lot of customers ask about, well, should I go EC2 native, or should I just leverage VMware Cloud and AWS and lift and shift? And I think it really depends on what's the right solution for you. So there's some customers where a 3-node cluster, which is the minimum, with 1.5 terabytes of RAM is just too big of a cluster. In which case, I have some customers that only have a few instances, in which I say, it might be easy to move those to EC2. Where it makes more sense for the VMware Cloud on AWS offering is where you really want that native VMware experience. You have VMware administrators, you are a VMware administrator yourself, you're familiar with this environment, you know how it works, you have automation and tooling set in place, Revisualize Ops and others. It provides a really low lift to migrate into a cloud environment. So with very little backend lifting and reconfiguring, you can move natively to AWS through the VMware Cloud and AWS offering. So even though it's VMware, you're in a cloud environment and you can get there quickly.
Yep, and also, as James pointed out, it's fast. No changes required to your application because you can extend layer 2. And there's no lock-in. You can always migrate back if needed or if necessary. So it's a very flexible solution, and also you can get higher availability by changing the architecture of your application, deploying it on a stretch cluster, in addition to the high availability options you already have with MS SQL. So it just enhances the application that much more. So there aren't many other questions, but we'll talk about, or we'll discuss a few questions that normally come up with other customers. For example, do we need NSX on-prem? No, you don't. There's no need for NSX on-prem. All the features that we've discussed can be, you can achieve without NSX, and layer 2 extension can be provided using the hybrid cloud extension tool. Storage options usually come up also. Customers asking us, what flexible options do I have, or what options do I have with regards to storage in these hosts? So we have 2 host types. One is the i3.metal, which comes with internal NVMe storage, and the second is the R5.metal, which uses what we call elastic vSAN, which is using EBS as the backend storage. So 2 different host architectures, providing a little bit more flexibility on the storage, where storage is not within the host and therefore can be extended without adding hosts. Are there other questions that your customers usually ask you, James?
I think another question that comes up often is how do I get connected? So what's that hybrid story look like for connecting my SDDC running on-prem to my SDDC running in the VMware Cloud and AWS environment? The good news there is it's pretty simple now to just create a virtual interface on your Direct Connect connection. Direct Connect is our private fiber offering, which is private fiber into the cloud. And on that connection, you create virtual interfaces. So we can just provision a new virtual interface. And then from the VMware Cloud and AWS GUI, we can put in that configuration and get everything linked up. So we have high bandwidth, low latency connectivity into AWS from your on-prem environment. And that's actually pretty simple to get set up and just use a virtual interface on a Direct Connect.
Excellent. Another question that usually comes up is regards to tenancy. James did mention this. I'll just reiterate it. It's a single tenanted solution. The hosts are deployed for you only, and they're your hosts on which you can deploy anything you want. The consumption model is per host versus per VM in native AWS. So you have uh, two ways of consuming the host. You can purchase a single node SDDC, which is just a single host, which is normally used just for test and dev. Production workloads are not recommended on that. And the minimum size of a cluster for production workloads is 3, up to a maximum of 16 hosts. And you can have up to 20 SDDCs within a single deployment, organizational deployment of VMware Cloud and AWS. And anything else that we want to, any other questions we want to bring up, since there are no questions in the chat? The platform is fully API driven. There's an API Explorer, which helps you understand how to use the APIs and test the APIs. So all operations that can be done within the SDDC can be run by via API. So the existing automation tools that you use now can leverage those. And any existing tool you use to manage your on-prem VMware infrastructure can be used to manage this one. So it's just an extension or another virtual data center that you're managing within vSphere.
And it looks like we do have a few questions. So this one is, what level of support you offer compared to, say, Rackspace or DigitalOcean? So I think what's unique about this offering is it is the only VMware Cloud offering that's native on a provider. So if anything else out there is typically something being resold through a partner, whereas this VMware Cloud and AWS offering is a native offering where VMware has redesigned and restructured their ESXi environment so it works optimally on bare metal EC2 instances, and you're not going to find that with other providers out there. So it is a truly differentiated solution, and it's cloud native, whereas we can automatically grow clusters, scale in, scale out. You won't see that type of capability with other providers. You also support us directly through VMware. So if you have a problem with your VMware SDDC running on AWS, then you contact VMware, and they'd be the escalation path for maintaining and helping you with any issues you have.
And there's another question, how about migration from ESXi to native AWS? Well, that's supported currently with existing tooling. So this solution doesn't actually change that or enhance that or add anything to that. The existing tools that are available now to migrate from ESXi to native AWS still exist. Just keep in mind, when thinking about this solution, is that you have VMware VMDKs running on hosts which are supporting VMware's SDDC on AWS bare metal, running in AWS's availability zones and regions on AWS's infrastructure. So there wouldn't be a way of just natively migrating those VMDKs into AWS. That's not, you'd have to still go through a transformation of the image to an AMI image for it to run in native AWS. But any VM that's running on VMware Cloud and AWS can connect to any AWS service that's available within the customer VPC.
Yeah, and I think the key point there is that there's different use cases. So if I want to use something in AWS native, that's going to be certainly a different requirement and different type of workload than leveraging an SDDC connected to your on-prem environment, where you're extending your VMware Cloud environment into AWS. That's different than I'm just going to run an EC2 instance here. There are tools that can do that migration for you with varying degrees of success. So, I mean, really the true click button migrate the VMware Cloud and AWS offering, where we can natively live vMotion from your on-prem environment into AWS.
One question that sometimes comes up, very often comes up, is how do I manage the VMs that are running in VMware Cloud and AWS? So a vCenter is deployed with every SDDC, and this therefore gives you the ability to connect that. You can either manage your VMs from that vCenter, or you can connect that vCenter to your on-prem vCenter and manage everything from your on-prem vCenter. Within your on-prem vCenter, the VMware Cloud and AWS SDDC just looks like another virtual data center, and it's managed just the same as you manage your current environment. So a couple of things I should have pointed out at the beginning. We ran a webinar on Oracle last week. Francesca just posted the link to that. And so you can always download that to look at how do you modernize your Oracle workloads or innovate with your Oracle workloads on VMware Cloud and AWS. And we have another webinar coming up in October, I believe it is, on VDI. So you can look forward to that. So I don't think we have any other questions. So I think with that, we can probably sign off now. So thank you very much for joining us, and we look forward to speaking with you again on the next webinar. Thank you very much. Bye-bye.